Good morning, students. Welcome to JCE Connect e-learning portal. Here, we'll start with the first module of power electronics. In the previous class, we discussed about what all the subjects which we are going to study in this particular, what all the topics which we are going to study in this particular subject. Okay, starting from the beginning and still at the fifth, up to the fifth semester. What are the different concepts which we are going to study in this particular subject we discussed. Okay, and also we discussed about the brief introduction of power electronics and the history of power electronics, how the power electronics is began and how it is reached to the standards. Okay, that we discussed in the previous class. The history begins with 1956 and how it is evolved, how the power electronics and the power semiconductor devices, how it is evolved, that we discussed in the previous classes. Okay, and also what all the important concepts which we are going to cover in all the 5 modules we discussed. Okay, and also we discussed briefly about some what all the lab experiments which we are going to do in this particular power electronics laboratory, that also we discussed in the previous class. Okay, in this class we'll start with the actual module, actual concept. Okay, that is power electronics and power semiconductor devices. Okay, what is power electronics? I think definition is already clear. I will tell one more time. So power electronics is the application of solid state electronics that deals with the controlling and conversion of electrical power. Here not only control the electrical power, at the same time the conversion of electrical power is also takes place in power electronics. Okay, so here, so you will get the questions like how exactly your power electronics is related in control. What is the relationship between power electronic to power and electronic and control? Okay, then mention the applications. Okay, so in that case you will be have to explain this particular concept. Okay, this is a block of power electronics. Okay, control block of power electronics, that control block, it consisting of a power combination of power, electronic and control. So power electronics may be defined as the application of solid state electronics for the controlling and conversion of electrical power. We already discussed. So it is a generalized block which will represent the power electronic system. Okay, so here it will indicate the relationship of power electronics to power electronics and its control. Okay, that is the generalized block representation. So here, how exactly power in the first block? So here is a power, so which is power which deals with the static power or rotating one. Okay, rotating equipments for the generation, transmission, distribution of electrical energy. Okay, so here it may be analog signals and digital signals. Okay, then comes the electronics. So electronics is deals with the solid state devices. Okay, solid state circuits for the signal processing to meet the desired control objectives. Okay, next, controlling purpose. What exactly controls? So control deals with the stability and the responses. Okay, stability characteristics of a closed loop system. So this entire power electronics, these are the relationship of power electronics to power electronics and its control. Okay, so that is about the power electronic system. Okay, so this is the generalized block which will indicates the relationship of power electronics to power electronics and to control. Okay, that's about the generalized this one. So I'll just have some brief applications of power electronics here. So first application is home appliances. So home appliances means, so the power electronics, it has a variety of applications. There is no such there is no one such applications where there you cannot find the power electronics. Okay, so power electronics in all the field you will find the power electronic applications. Just I'll give you a few brief applications of power electronics. So it is used in the home appliances. Where exactly in home appliances? So if you are using a refrigerator, you find a power electronic device there. So if you're using washing machine, you'll find a power electronic device. Vacuum cleaners, mixer, cooking applications, fan, etc. You cannot you will find in almost all the electronic devices there is an application of power electronics. Okay, then comes the games and entertainment. So gaming objects, so gaming equipments like toys, TVs, projectors. Okay, electric cars, various toys, what all the toys which uses the electronic circuits which consisting of power electronics. Okay, then comes the commercial applications. If you're talking about the where commercially these power electronics are used, so advertising purpose, advertising boards, there the power electronics comes into existence. Next, battery charging applications. Battery charging means if you have a laptop, the laptop charging applications. So if you have mobile phone charging applications, almost all the electric battery charging applications, the power electronics is much needed. Okay, then comes the computer. So computer is also one of electronic device, so there also you'll find the application of power electronics. Photocopiers or Xerox machines, power supplies, that is SMPS, UPS, elevators, etc. There you will find these are the some of the commercial applications of power electronics. Next comes the automotive applications. Automotive electronics applications means so alarms and security systems. So alarm, burglar alarm you can say, or any security alarms. So there you will find the power electronic up systems. And also in case of electric vehicle, without the power electronics, your electric vehicle system will not be working. Then in medical fields also we find the applications of power electronics. So that is the laser power supplies. Okay, and medical instrumentation, it may be a surgical equipments. Okay, or it may be operation theater equipments, various equipments. In the medical industry also the power electronics is used. Okay, that is about the applications of power electronics. Next comes the block diagram of power electronics. So it is a generalized block diagram. In the previous in the previous block we discussed about the relationship of power electronics to power electronics and to control. Here we comes the generalized block diagram of power electronic system. Okay, so it consisting of what exactly power electronic system consisting of. So power electronic system consisting of a power source. So power source, you have a power source here. So controller you have, then load you have, sensing and feedback circuits you have, then control unit, then reference setting commands. So these are the main important blocks of power electronic system here. Okay, so this is a block diagram of power electronic system. So what exactly power source? So I'll explain one by one each block. So which consisting of, these are the main blocks of power electronic system. So I will explain one by one. Power source. What exactly power source? So power source may be your AC power or DC power, the supply which comes from the KEB or power generating station or from the batteries, that is a power source. Okay, then comes the power controller or converter. So power controller converter, what exactly it does? It consisting of a power electronic converter which converts one form of energy to other form. So if the power source is AC, it converts into DC if the load is DC. If the power source is DC, it converts into AC if the load is AC, based on the load which we are using here, based on load which we are using, so which will be converting the system. So power source is AC, if the load is DC, then it converts to AC to DC. The power source is DC, the load is AC, then it converts from DC to AC. It will be acting as an inverter, rectifier. Power electronic converter is nothing but it may be an inverter or rectifier. Then load you know already. So what all the electronic equipments which we are using, they are all comes under the load. We have a AC loads also, we have a DC loads also. So based on the load requirements, the power source will fed it to power converter which converts one form to other forms, then it is fed to loads. Okay, that's the process. So after that load, you will be having a sensing and feedback circuit. So to maintain the load requirement, to maintain the requirements at the load side, the power sensing and feedback circuits are very much essential here. So which senses the what exactly the load variation in the load. Okay, so variation in the load is sensed by this sensing and feedback circuits. Then the signals from the sensing and feedback, this is consisting of sensors. Once again, sensors and feedback elements, so that sensed signals are passed to the control unit. Okay, control unit once again. So which will be control unit is nothing but it is once again electronic device. So based on the signal which received from the sensing and feedback network, which will scan the commands to the power converter. So once again the power converter will do the necessary conversion, do the necessary functions. Okay, that is reference and setting signals is also, it is a additional signals which is given to the control unit to monitor the commands from the sensing and feedback circuit. So that is the generalized block diagram. So as I already said, so power controller converter, which may be such as whatever the switches you can use here, you can use SCR, GTO, MOSFET, BJT, any switch can be used as a power converter. So then power source can be mains, AC generators, AC or DC, as already explained here, so which is suitable based on the applications. So which is power converter will convert it to our another form. So let me take an example of speed control of a DC motor. The power converter and the controller is controlled rectifier which provides the variable DC source. So if the DC motor and the AC supply if we are having, then the power converter is consisting of a rectifier which will rectify the supply voltage of AC to DC, then it is fed to the your motor. Okay, then comes that is about the block generalized block diagram representation of power electronic system. Okay, that's a power electronic system. Then comes power semiconductor devices. Power semiconductor devices, what exactly all the power semiconductor devices which are used as on-off switches in power control unit, all the power semiconductor devices you can take, so which are used as on-off switches in the power electronic system or control unit. So these power semiconductor devices are classified as follows here. So the power semiconductor devices are classified in the three types. These power semiconductor devices are classified into three categories. So first one is the diodes, then comes the thyristors, then the transistors. So these power semiconductor devices are classified broadly into three categories. So which are those? So general purpose, diodes, okay, thyristors, and then transistors. Okay, in diodes we have a various types of a diode. Okay, general purpose diode we are having, high speed diode we are having, then Schottky diode here. So in diode we have a three categories: general purpose diode, high speed diode, I mean high speed type of diodes, then Schottky diode. These are the three different types of diodes we are having. Then comes the thyristor. So thyristor is once again, what all the different switches which fall under thyristor family is SCR, GTO, RCT, okay, then SITH, LASCR, MCTs, triac. So SCR is silicon controlled rectifier, GTO gate turn off thyristor, SITH is a static induction type of thyristors, LASCR is a light activated silicon controlled rectifier. So MCT is a master controlled rectifier. Triac is a triode for alternating currents. Okay, and many more type of the thyristors are there. So in this about the thyristors, in detailed classification and in detailed constructional features and in detailed characteristics of these thyristors we will be studying in the third module. Okay, just I will concentrate to the next. So in the second module will be transistors we are having. So transistors, once again it is a BJT, that is bipolar junction transistor. Okay, this already studied in analog electronic circuit. Then MOSFET, that is metal oxide semiconductor field effect type of the transistor. Then third one is IGBT, that is insulated gate bipolar junction transistor. Okay, then SIT is static induction transistors. Okay, so here the different types of transistors and the thyristors will be consecutively we are studying in the third and fourth module respectively. In the first, here in first we will be discussing about the diodes, okay, rectifiers and many more. So these power semiconductor devices are classified as these three categories, that is general purpose, diodes, thyristors and transistors. This is a classification of power semiconductor devices. Okay, next. Next is power diodes. So power diodes, you already know what exactly power diodes are. So power diodes are required in most of the power electronic converters. So So normal diodes and power diodes, the difference is there is a rating voltage and current handling capability of the diodes, that is a difference. So power diodes are required in most of the power electronic converters. So if you take any power electronic converters, so power diodes are required. So power diodes is a uncontrolled devices. Why it is uncontrolled, we can say, so there is the user cannot have a control on its turn on and turn off. Okay, that is why it is called as a uncontrolled devices. Okay, so power diode, any diode is an uncontrolled diode. If it is receives the higher polarity at the anode side than the cathode polarity, then it starts switch on. Okay, so that is why it is called as a uncontrolled switch, uncontrolled device. So there are three types of power diodes. Then first one is general purpose diode. So first type is general purpose diode, second one is high speed or fast recovery diode, third one is Schottky diode. So these are the three types of power diodes here. Let me discuss about one by one. So general purpose diode, so these have a highest reverse recovery time. What exactly reverse recovery time, what exactly reverse recovery characteristics, we will explain in detail when while explaining the characteristics of diodes. So just reverse recovery time is nothing but the time required for the diode to recover from off state to one state to other state. Okay, that is a reverse recovery time of the diode. So it is off state to on state, that is called as a reverse recovery time here. So here these general purpose diodes have the reverse recovery time of 25 microseconds. Okay, 25 microseconds it is having. Hence these are used in the low speed applications such as rectifiers and converters, as the reverse recovery time is less, so it is used in the rectifiers and converters, right? Then they can operate at the frequency, the operating frequency of this general purpose diode is 1 kilohertz, and the ratings are ranging from 1 ampere to 1 ampere 50 volts to 1000 ampere 500 volts. So the current capability, the current voltage handling capacity is ranges from 1 ampere 1000 ampere to 50 volts to 500 volts. So that is the power handling capability of the diode. Okay, next comes the fast recovery diode. Fast recovery diodes is nothing but these have the reverse recovery time of less than 0.0 sorry less than 5 microseconds. So in the previous it is 25 microseconds. Here they have recover, that is they come from off one state to other state in a very less short of a span of a time, that is 5 seconds is enough to recover from one state to other state. So that is why it is called as a fast recovery. The name itself says fast recovery. So they are recovered from one state to other state in a very fast manner, that is why they are called as a fast recovery diode, and the reverse recovery time of such diodes is 5 microseconds. Hence these diodes are used in high speed applications such as choppers and inverters. So in the previous it is used in the rectifiers and converters. Okay, general purpose. So fast recovers are used in the choppers and inverters. So the voltages, these diodes have a range of voltage is 1 amp 50 volts to 100 amps 30 kilovolts, 3 kilovolts. So 3 kilovolts, just you can imagine the how much the voltage and the this fast recovery diodes has capability to handle it. Okay, then comes the Schottky diodes. Schottky diodes, so it is a generalized constructional diagram of a Schottky diode. So it consisting of a semiconductor material, semiconductor N type of P type of semiconductors, you know, different types of semiconductor material we are having. So which is made up of with the all the power semiconductor devices are made up of with the different types of semiconductor materials only. That's also consisting of different semiconductor configurations. Then metal strip is attached on that. So and the metallic part which is connected to the semiconductor material will be acting as an anode, and the other terminal which is connected directly to the semiconductor will be acting as a cathode, and there is a junction between the semiconductor metal and the semiconductor is formed here. Okay, that is a just a general constructional feature of a Schottky diode. Then this in Schottky diodes, what happens? Schottky diodes, the PN junction is eliminated here. A thin film of a metal is placed directly on the semiconductor, as I have shown here. The thin film of a metal is already placed directly on the semiconductor. Aluminum is deposited on the n type of semiconductor. A metal and the anode, semiconductor is cathode. So metal is an anode, semiconductor is cathode. I already told it. So hence there is no PN junction. The storage time is absent. So there is no NPN junction in this type of diodes. The storage time is absent. So storage time is absent here. So turn off is very well small. So Schottky diodes have a very high switching frequencies. So compared to other type of diodes, the Schottky diodes have a very higher switching frequencies, and these Schottky diodes are used in the low voltage converters as a feedback and freewheeling diodes. So feedback and freewheeling diodes it is used. Next comes the applications of your power diodes. So applications of power diodes. Okay. First application of power diode is power diodes are used in uncontrolled rectifiers. So power diodes are used in the uncontrolled rectifier. Rectifier is nothing but what? It is a conversion of AC to DC. Rectifier is an electronic circuit, power electronic circuit, which converts the alternating current to direct current. Okay, so these power diodes are used in the uncontrolled rectifier. Uncontrolled rectifier is no what? So if you are using the control switches, then the output voltage can be controlled, the variation of the output voltage can be controlled. That is called as a controlled rectifier, that we are discussing the fourth module, I think so. So uncontrolled rectifier is nothing but we don't have any control on the operation of these switches. That is why it is called as an uncontrolled rectifier. So power diodes are used in such uncontrolled rectifiers. So the feedback and freewheeling operations in this chopper are inverter and controlled rectifiers. There you are using the power diodes. So it is used as a freewheeling diodes, freewheeling operations in choppers. Chopper is nothing but DC to DC converters. Inverter is nothing but which is DC to AC converter, and controlled converter you use the power diodes. Then almost all commutating circuits for SCRs we use the power diodes. Commutating circuits are nothing but, so diode once the SCR is turned on, it does not have control on its turn off. Okay, to turn off the SCR we have using commutation circuits. So such commutation circuits we are using the power diodes. Okay, then almost all commutating circuits it is used, and half controlled converter and half bridge inverters we are using the power diodes. Okay, so that's about the power diode. Then comes the types of power electronic circuits. So here in this previous slides we discussed about what exactly power electronics and applications of it, and about block diagram representation, how the power semiconductor devices are classified, and one classification we discussed power diodes. Okay, here the types of power electronic circuits. So types of power electronic switches, right? So we'll discuss about types of power electronic circuits. So power electronic circuits can be classified into 6 types. These power electronic circuits are classified into 6 different types. One is diode rectifiers, they are also called as uncontrolled rectifiers. Next is AC to DC converters, they are called as a controlled rectifier. Next is AC to AC converters, they are called as a voltage converters, AC voltage controllers. Then DC to DC converters, they are called as a DC choppers. Then we are having a static switches. Okay, static switches, and one more will comes, that is a cyclo converter. That is a 6th type of cyclo converter. Okay, so here we will discuss about the first diode rectifier. Okay, this is a diode rectifier. So here a diode rectifier, okay, this is a block diagram representation of a diode rectifier. So here we have a given the input of single phase or three phase AC supply. So you can see the input is a single phase or three phase AC supply. It is a AC to DC converter, and output is fixed DC output voltage here. So fixed DC output voltage. So it is a general block diagram. So here we have a circuit. Okay, circuit consisting of a AC supply and so center tapped transformer, so which is given to the two diodes D1 and D2 is used. So when the supply is given, so in the first half cycle what happens, so diode D1, anode of the diode D1 will receive the positive polarity, and the anode of the diode D2 receives the negative polarity. See here, so the input voltage is applied. So here the input voltage is applied. So anode of the diode D1 is getting positive polarity, diode D2 is getting negative polarity. So diode D2 is off. Okay, and similarly the supply is passed through your diode D1, so which is also the current is flows from this to load here. Okay, so your positive cycle will arise here. So in the second half cycle what happens, so anode of the diode, so this in the negative half cycle, so here it is the negative half cycle, the diode D1 receives, this is during a positive and the supply is positive, and the supply is negative, so the diode D1 receives the negative polarity, whereas see here, so here already it is negative, so negative is positive, the diode D2 receives the positive polarity. So because of those two polarity issues, so your another half cycle of AC is converted into DC form here. Okay, that is how the both the diodes will be acting simultaneously to produce the DC output voltage here. Okay, diode here it is explanation is given here. So Vm is the maximum voltage, Vs is the supply voltage, Vs is equal to, you can calculate Vm by root 2, and this is the output voltage which is given below. Okay, so here diode rectifier circuit convert AC voltage into DC, which I already explained. So the input voltage to the rectifier Vi could be either single phase or three phase. As I said, it may be a single phase or three phase. We can convert three phase, we have circuit is a little bit different, single phase the circuit is different. Okay, so that is based on the phase the circuit is varies here. So as it is a single phase rectifier, so this rectifiers can also be used for the three phases also. Okay, next is AC to DC converter. Right, AC DC converter or controlled rectifier. So here also input is a single phase or three phase, AC means DC converter. So here output is variable DC output voltage here. Here also the supply voltage is given and the center tapped transformer. Instead of diodes we are using the thyristor here. Okay, thyristors are fired, thyristors are not it is a controlled devices, thyristors are the controlled switches, diodes are the uncontrolled switches. So here thyristor operations can be controlled by giving the by applying the required gate pulses here. So by applying the required gate pulses, the thyristor operations can be, this is your gate terminal, thyristor is a anode, cathode and gate. Okay, so the operation of the thyristors can be controlled by applying the firing angle. So here it is alpha is nothing but your firing angle. So up to here your voltage your thyristor firing pulse is not given to gates. Okay, so what is the condition for the gate thyristor to operation? So this is your thyristor. Okay, this is your gate. So here it is a anode and cathode. So if you give a diodes, if you give anode and cathode polarity, it will act. But for thyristors, along with the anode and cathode, it is requires a gate pulse. Okay, gate pulse is nothing but it is a pulse which is generated from the firing circuit. So it is required gate pulse. So without gate pulse, your thyristors will not be operating. So the angle which is varied to apply the gate pulse is called as your firing angle. This is your angle here. This is the firing angle. So up to here thyristor is off. So once the up to here anode and cathode supply are present, sorry, okay, then but gate is absent. So once the gate is present, gate supply is given, so your thyristors is conducting here. Okay, so see here, here anode is positive, cathode is negative, so it is not conducting. So this is your input. Okay, this is your output, but you see So anode is positive, cathode is negative during the positive half cycle. So but the output voltage is 0 here. Why? Because the firing pulse is not yet given. So once the firing plus pulse is given, so from here onwards the firing pulse is given, the output is starts transferring the power from input to the load side. So similarly, so in the second half cycle, it is negative supply is applied. So this is reverse biased and this is forward biased. Along with that, the gate pulse is applied. So here up to certain time, so up to which when you here the gate is absent. Once the gate pulse is applied, your SCR starts conducting and it will transfer the power from low supply to load here. So during positive half cycle, this SCR will be acting and transferring power from load input to load. So during negative half cycle, this diode is acting, okay, and it is transferring the power from input to the load side, okay. That means which is converting the power to load here. So here DC to AC converter, it is also called as a controlled rectifier. So here it is diode rectifier, it is controlled rectifier, okay. That is the difference, okay. The other types of the circuits we'll discuss in the next class, okay. If you have got any doubts here, you can feel free to contact me anytime. Thank you.